All right. Good evening, everybody. Welcome to the fourth and last day of the AppSec. Uh, I am not very in it tonight. I have forgotten to share my screen with the rig, so I'm gonna fix that momentarily. This is the thing that you get where you're thinking you're all prepared and then realize that, hey, I forgot something. Output HDMI 1 mode 1080 and let's go back to that. Go back to him. He goes away, exit. Oh, this is always a joy. Always, always, always a joy. I see what's going on here, so I need to tell that. And then we enter full screen. Now Zoom is being very, very evil. I'm gonna leave it like that. Yes, people, sometimes stuff like this is very, very difficult. And I'm gonna move close enough. That goes there. Right, so hopefully you should now see Anastasia, who is going to be our opening speaker today. She's going to talk about maintaining a crypto library in 12 languages. As ever, if you have any questions, please post them to the YouTube comments and I will ask them to Anastasia at the end of the talk. Anastasia, take it away.
Hi, hello, good evening. It's evening for you, it's evening for me if we are both located in Europe. Because, with these online talks, kind of never know where people are. So if you just woke up, good morning, but I hope it's the end of the day for you. So relax, because we have super interesting talk. Because it's a talk about cryptography, obviously. The crypto is interesting, right? And let me share my slides. Probably I'll share, yeah, in the YouTube comment section, I will share a link to this talk because this talk I've done previously. So if you would like to watch like the slides, you can do it from the link. I also would like to mute everyone else who is on this call, please, because I hear the noises. Okay. So let's continue. Yeah, maintain cryptographic library for 12 languages. Well, it's not 12 anymore. It's even more. It's 14. I just stopped counting. So my name is Anastasia. My nickname is Vixentile. You can follow me on Twitter. And as I mentioned, the slides for this talk is available in Speaker Deck already. So if you don't want to listen to me, if you don't want to watch this talk, just go to the Speaker Deck and click the slides. Actually, Speaker Deck has much longer version of this talk. So what do? I was a software developer, really happy, really excited, doing a lot of mobile applications until I discovered security and security engineering and security architecture and especially cryptography. Then I switched my career a little bit and now I'm into security and then basically I'm maintaining cryptographic libraries, I'm creating security software, I'm working with developers to improve security of their applications. Well, and my super hobby is creating end-to-end encryption schemes, implementations for mobile applications. I work at Cossack Labs. This is data security company. Basically, we are like vendors of security software, and what we do is protect the data all the time. So we have a lot of open source. We have a lot of solutions for data protection, mostly encryption, a lot of encryption, a lot of encryption related research, like searchable encryption or end-to-end encryption data collaboration, all the things are public and most things are public, so you can check it out later. In short, in crypto we trust, but not in all kind of crypto, in usable crypto. In cryptography that doesn't require from developers, people kind of responsible, for security of their applications, really understanding cryptography. And one of the topic of this talk, and one of the things I do in my life is during long evenings, I support cryptographic library. I'm not the only one to support it. I work with a team, and this cryptographic library is a Themis. It's like 4-5 years old already. I started doing it as a mobile developer like many years ago, like being responsible for mobile part, but then I just spread like everywhere. So when I tell in usable crypto we trust, I meant that cryptography should be boring, meaning it should not be exciting. It should be like really easy to use, really hard to misuse. And this is what we're going to talk about today. I won't dig into cryptographic details a lot, just because maybe this Thursday evening is not the best time to dig into crypto. I will start to be on the level of security design, library maintaining kind of scale. Okay. So as a cryptographic library, Themis is used in multi-platform application mostly because it supports so many platforms. So developers select this library when they create their apps for a couple of platforms like iOS and Android application that has some backend on Node.js, for example. Instead of using cryptographic libraries for each of the platforms, they just use Themis because it has similar API. It works on these platforms. Of course, as one of the examples, for example, as I mentioned previously, like end-to-end encryption is kind of my hobby. This is an example of implementing end-to-end encryption in Bear application. I was kind of leading this project. This is end-to-end encryption in AppSpectre application, which is a remote debugging tool for mobile apps. Both of them are built on Themis because it makes work really easier. And today I'm gonna complain a lot. I complain about platforms, cryptography, and how complicated it is to support a library. The idea behind Themis is that it's built around the use cases, not like cryptographic primitives, but use cases for developers. As a developer, I want to store data securely, verify data, send data securely, right? And for this purpose, Themis has something that we called crypto system. So crypto system is basically like explains the main use case. Secure Cell, for example, crypto system, it provides API for storage encryption. If you ever used Lipsodium, think about Secure Box. The idea between Secure Cell and Secure Box are more or less the same. Secure Message is a crypto system for encrypting messages for someone, right? So public key encryption. Secure Session, well, obviously, it's kind of encrypted communication. Think about TLS 1.3. And authentication, like Secure Comparator, is a crypto system above zero knowledge proofs protocol, interactive zero knowledge proof protocol, which allows you to compare secrets on both sides without actually sending the secret in a network. And just a couple of words before we get to the like complaints, a couple of words about Themis structure. I like to think about Themis as about a cake because it has this multi-layer structure with some crypto backends, because obviously, yeah, we have cryptographers on board, but we don't implement our own crypto too. So as a source of cryptographic primitives, in Themis, we use OpenSSL, Boring SSL, which is fork of OpenSSL, LibreSSL, or for very custom use cases, we use custom cryptographic engines. For example, a native Go cryptographic library, basically Go crypto native package. We use this, we can build a version of Themis that doesn't use OpenSSL, but uses Go crypto instead. Right. Above the crypto backend layer, we have basically the Themis core layer that works as links between complicated OpenSSL API and high-level API. And the upper layer, the last layer, is language wrappers. Basically, for all these like 14 platforms and languages, we have wrapper. I call them platforms and languages because WebAssembly is not a language, right? It's more or less like a platform, but still it requires separate library. Or Node.js is not a language, it's a platform, right? But and JavaScript and different JavaScript frameworks like platforms, they again require a little bit different. So yeah, I call them just languages / platforms just because. For iOS, for example, that's a platform, and languages we support is Objective-C and Swift. Okay, so what is complicated for them is that cryptography needs to run anywhere. In all these operating systems that developers use and servers use. So we support tons of operating systems. I actually tried to make this slide super simple because previously on this slide they had all the operating system. It was more than 10 probably. And for each of them we create this like the package, right? So user could install it. And let's talk about that a little bit. You probably know, you probably heard somewhere a term boring crypto. I hope you heard because I like it a lot. And basically this is the idea suggested by Daniel Bernstein many years ago. I found like his talk in 2015, like 5 years ago, almost 6 years ago. The idea behind boring crypto is this is like a good cryptography. Boring means good, okay? So this is a good cryptography that doesn't require from you as a user of crypto, doesn't require updating cryptography, understanding cryptography. It just works like perfectly. It's boring. It's not exciting to use this kind of crypto. Another idea I really like, and another idea which were like part of design ideas of Themis, but again, Themis is like 5 years old. So this is not like, these ideas, they exist in security space and many people tell about them. The thing that Bruce Schneier told recently in an interview we were making with him at NoNameCon conference, idea about no options. So don't give options to users because users will mess it up. Just give them one large button, one option, like what to do by default, nothing else. So Themis is really great like interpretation of these ideas because a lot of bugs in applications that use crypto libraries happen not inside crypto libraries, but inside applications because misusing. Because crypto is complicated and developers misuse cryptographic libraries. And here is a question I like to ask the live audience a lot, but I imagine that you like listen to me and answer the question. So I usually like to ask them, what do you think for cryptographic library? Basically for any library. What's more important? That this thing is easy to use or that it's hard to misuse? And of course, like people, raise their hands, but this is a tricky question because both of them are important and they're like yin and yang, they don't exist without each other. So easy to use means that if it's complicated to install your library, no one will use it. Okay, this, for example, the installation of OpenSSL, of course, you kind of need to compile it first. And most modern developers, they won't do it, right? They will just type something like brew install OpenSSL, and if it's not there, sorry. So for Themis, for example, with all these operating systems we have, for each of them, we needed to create like a package into their package manager and submit Themis there. So developers could install it like in one line. You see here, brew install libthemis, yeah, of course, just because. Otherwise, how macOS developers will install it? But this is not a question only about operating system, but about languages as well. Because if I work on macOS, for example, but I use Python, I would like to use like pip install pythemis. If I'm a mobile developer and I use like something else, I use CocoaPods, I should find Tempest there. So with all these 14 languages and all these operating systems, imagine that most of them have their own package manager. And developers use these kind of industry proven, like language proven package manager. And if your library is not there, sorry, they won't find it. Or if they find it on GitHub, probably they won't install it just because it's too complicated. And it's especially complicated in iOS world, for example, because for iOS, we have not only one package manager, we have like 3 package managers, which is CocoaPods, community built, centralized package manager, Cartage, community built, decentralized package manager, and Swift package manager, which is a brand new thing built by Apple. And if you want to be like successful library in iOS world, you need to support each of them, which is tricky because they're like totally like 3 different species. And for example, in Tempest, we do support CocoaPods and Cartage, but Swift package manager, it was so unstable. Sorry for complaining. So we start doing this support, we start digging only right now with Apple Silicon. Oh, Apple Silicon. Oh, I love iOS, really. I was mobile developer for many years, but some ecosystems, they're always changing. And as a developer, if you create library for this ecosystem, you're pushed to always change your library. Not because you want, just because it will stop working. In iOS, we have so many complaints from users because new Xcode version, new iOS version, new macOS version, because some things was changed, right? And because something is not working, so need to dig in, need to find, need to fix, and release the library again. Not because you want to implement some changes, like the core, the cryptographic core in Tempest, it's not changed for, I don't know, like 3 years already. It's kind of stable. It's more like integration. It's more like packaging that is constantly changing, or small fixes and improvements that we make in API to make it even more usable. But literally, and with Apple Silicon, with Apple Silicon, we have so much troubles. But now Tempest supports Apple Silicon. Yay! And we already have applications working on Apple Silicon. But yeah, it was a little bit unexpected, to be honest. And I spent part of my summer, I literally spent building and rebuilding OpenSSL for Apple Silicon. Yeah. Luckily, I have good MacBook and it's kind of fast, but still, it's not something you would like to do in your life if you think about it. Rebuild OpenSSL one more time because new architecture. Yeah. Okay. So this was like easy to use, right? If developers can't install your library, they probably won't use it because they can't install it. And it's your responsibility, like, sorry. Now, next, hard to misuse. I like to think about it as about like the curve. When we were doing training with Jean-Philippe, with JP Omasan, we call this curve a pain curve. Basically, it means that the more flexibility your library or your tool has, the more complicated it is to use, and vice versa. If you want to have easy to use tools, they don't provide much flexibility, right? So in Tempest, for example, and you can compare yourself different cryptographic libraries with this parameter. In Tempest, for example, we are more like a crypto system level here because it's 4 crypto systems, 4 use cases, and you don't have much flexibility. In some cryptographic libraries, they're more like library or even like Cypher. OpenSSL is more like Cypher because you can have huge flexibility in OpenSSL, but cost of it is huge amount of code and calling OpenSSL and clearing buffers and so on and so on. So as example, this is how Common Crypto API looks like. Common Crypto is like, it was main developer facing library for Apple, for iOS and macOS. And now we have another one. Now we have CryptoKit from Apple again. So this is how Common Crypto API looked like. And this is just iOS encryption. So it should be like a super easy encryption. As a user, I just want to encrypt the data, but you see how many parameters here, and you can imagine how many mistakes as a developer you can do here, right? Fortunately, in iOS world, there are a lot of libraries, community built. Unfortunately, some of them have complicated to spot mistakes that if you don't understand crypto, you probably won't find mistakes. So this is like an example of one of the libraries which looks much easier than Common Crypto and became super popular. The same thing on this screenshot, which is like a screenshot from README I took, I know, like 2 years ago, probably a year ago. It still has at least 2 mistakes using this static key and uses this static init vector, right? And we don't know what's happened there under the hood. So many developers, if they don't know crypto, they might just copy paste it. They won't know that cryptographic key should be long and as random as possible. They don't know that IV probably should be long and as random as possible, not reusable, blah, blah, blah. So they just copy paste it, they make mistakes. But API looks easy, right? In Temis, for example, we also have this easy looking API, but we try to eliminate the source of mistakes as much as possible. We just don't give users this control. We don't give IV, we don't give nonce, we don't give users the ability to put like buffer or like buffer length. We don't give them an ability to select cipher. It's all been decided by Temis. We have specification how it works. Like we implement this cryptographic envelopes, like cryptographic data that is being returned by Temis. But for developers, this should not be like an issue. Developers should not think about that, right? We even have APIs that takes passphrases, not keys, but passphrases, and derives cryptographically strong keys from passphrases. Because developers, they don't distinguish key and passphrase. And it's fine. People without cryptographic education, they don't distinguish these things. And it's fine. Like cryptographic libraries should not expect that at least we don't expect in Temis that it will be used by cryptographers. We expect it to be used by developers. So we try to eliminate these kind of errors. And again, as I mentioned in the beginning, as Temis has all these languages and platforms, we try to have as the same API basically everywhere. Really similar. Of course, like JavaScript and Python are different, but we try to have APIs much similar as possible. Now, a little bit of like complaining or like telling what's going on under the hood when you as a developer use some shiny third-party library. Some libraries require a lot of testing. We in Temis, we do a lot of testing, like we are super lazy developers, and we don't rely on our brains, we rely on auto tests. For example, we have this source folder, and it has 35,000 lines, right? So all sources for Temis for core, which is a lot, but not really. And we have this tests folder, which has 340,000 lines, 10 times more, right? So amount of lines for tests are 10 times more than for code itself. Just because we need to test everything. And we use these multiple levels of testing. The first one is unit test, obviously, for each language. A lot of tests for core, for Temis core, which is written in C. And now in 2020, I would not recommend anyone to start library in C. We our Temis maintainers team, we really look at the Rust. If we ever decided to create yet another cryptographic library, it would be Rust, probably. So we have these unit tests, and we have especially a lot cryptographic tests, NIST test for cryptographic part of things. And of course, we rely on tests by OpenSSL, Boring SSL, and so on. Then we use fuzzing. We use fuzzing a lot to randomize inputs for functions. We found a lot of really interesting bugs using fuzzing, especially when fuzzer decides to use super long integers, for example, especially on 32-bit systems. Sorry, 32-bit systems. Then a lot of memory tests and static analyzers like clang, Walgrind, split, splint, C++ check. Integration tests. This is my favorite ones because many years ago in Themis we didn't have integration tests, and suddenly we understood that our single API for all the platforms actually behaved differently for some of the platforms, and we didn't know that because we didn't test these combinations. Now with integration tests, we basically test all the language that is compatible, fully compatible with other languages, just to make sure they work, that users can encrypt something in like Python using Themis and then decrypt it in like Ruby using Themis, or like Go using Themis, and results will be the same because languages are tricky. And of course, we have backwards compatibility tests that each of Themis versions is backward compatible with like at least one previous or maybe like two previous versions. So yeah, a lot of testing. We explained, actually, we have a really nice series at Dev2 where we explained what tools we use and give some advice if you want to automate testing for your project, for your library, not only cryptographic library, like any kind of library, like a project. Maybe you can find some tools there in a link. And of course, a lot of auto tests require a lot of CI/CD, right? At least CI in our case. CD is kind of, we don't want to automatically release cryptographic library a lot of times. So in our case, we use several CI services, like for different purposes. So for public parts, we use Circle CI a lot. We use Bitrise for iOS, Android, macOS specific parts. Now with GitHub Actions, we actually moved some of our workflows to GitHub Actions because they're like part of GitHub, and it's easy to integrate them, and it's kind of cool. And we also use a lot of BuildBot as our internal tests for all these long tests like integration tests, backward compatibility tests. In BuildBot, we write scenarios like, imagine I'm a user and I have some new Linux, like empty, fresh, without any like Themis installed. And I'm installing Themis and I'm doing some tests. This kind of clean state tests, they help to understand if everything is okay with dependencies, the things we rely on the clean operating system. But they take a long time, obviously. Of course, any library, especially security library, especially crypto library, requires security testing. In our case, we constantly look for correct memory management, especially zeroing of data, especially zeroing of like private data, some secret keys, etc., etc. And here are some links. If you do something like with cryptography, here are some links about about guidelines for crypto coding. And we rely on internal audits and external audits, and some contributors, like some people who help us or who are interested in Themis, sometimes they send us, this line looks suspicious. Yeah, we often receive this kind of, security reviews, let's put it this way, and that we start investigating together with that person if it's like a bug, if it's exploitable. So yeah, some kind of bug bounty program. I don't know. Themis is more like it's free and open source, so it's not like we have some specific bug bounty program as companies do. No, but still, we try to work on security like as much as possible. And to wrap up, I will tell you one more interesting thing about users. If you ever created a library, a tool for users, you probably get like a lot of questions, especially if your tool is related to cryptography. So like in our case, for example, we have a lot of documentation for each language, how to install, how to use, how code looks like, and then like general documentation that explains crypto systems, that explains possible attacks and ways to protect from different attacks. It explains general security guidelines because cryptography is part of security system. And if you use good cryptographic library, but you put your secret key somewhere on, somewhere like in a code, you hard code your key in a code, using of cryptographic library becomes not really useful, right? So we have a lot of things in docs. But of course, developers complain because they need to read these docs, right? No one wants to read docs. Okay. So we have how we call this safe to copy paste code snippets. So you can, if you want like to encrypt data, you just kind of copy paste a snippet, paste in your application without reading a lot of docs. But of course, developers start asking like, okay, this is a super simple snippet, but I don't really understand how to use it in my app. Okay. For this case, we have example application, like example apps, right, that have all these code pieces, and you can install this example application and like see it as a part of application. And again, let's compare the number of lines. You see that's like million lines, so a little bit more than source code and tests. Everyone likes example applications. But of course, developers can say, hey, this is your example application and it's working, but I'm building my own application and it's not working for me. I don't understand how to use it in my application. Okay. For this case, we have tutorials and use cases, some kind of real world application with some purpose, right? This explains some use case, like secure chat, for example, or like secure storage. I see here. Honestly saying, we haven't updated a lot of these tutorials a lot. We mostly update sample applications, but still, there are some community built tutorials. So for people, they can just download them and try like the real app. But of course, again, the complaint can be the same. It works in your app, it doesn't work in my app. What I'm doing wrong? And last step here is Codeless Simulator. Is a web page that we created, which also has a web server with Themis. And it allows you as a developer, if you have like encrypted code by Themis, you can just copy it there and decrypt it to make sure that everything is correct, that you configured Themis correctly. If you want to test a secure session, which is like a secure connection between two parties, you need two parties, right? And it might be complicated to create code for two parties at the same time. You can use our web page as a second party. So like communicate securely with the web page. It makes debugging easier. And yeah, it probably is like a last point. And some developers, if like some people open pull requests and time is something not working, we ask them to check with the simulator first. And often it might be some configuration error on their part, like wrong base64 encoding, something like that. It really helps. So yeah, 1, 2, 3, 4, 5, one README is not enough. As a library creators, you kind of responsible to make your library like understandable for your users, especially if it's cryptographic library, especially if users are not cryptographers, but developers. Now, the final thing here, I just want to like to notice that some libraries are complicated. Maintaining libraries is very complicated. Literally, if library supports several platforms. It's a hell for maintainers. Just say thank you if you use a lot of third-party libraries. Just say thank you for the maintainers, because yeah, it might be really tough. And the third point is, it's really cool that this kind of libraries exist. And as developers, we don't need to spend time to understand all this, especially on crypto. We can just select cool libraries and use it. So yeah, let's wrap up. And thank you a lot. This is my nickname. You can follow me on Twitter, or you can watch the longest version of the same talk, like the slides in my speaker deck, because I put more information there, including Android, more things. Okay, so let me check if you have something on YouTube.
We do.
I see the question actually. Yeah.
We do.
I
We've
see a
got
question.
Aram Hofsepijn. I hope I'm probably completely butchering the name. What about performance of Themis? Is it comparable to the regular libraries?
Well, it depends. For example, for OpenSSL, I could say that performance of Themis is comparable with performance of OpenSSL, because we built OpenSSL with all these hardware acceleration flags, yada yada. So think about it. Themis is about layer above OpenSSL, which adds you some performance drawback, but not huge. At the same time, we have this version with native Go, and so native Go library, Go crypto, Themis Go library without all the C stuff, and it has much better performance than OpenSSL C Go, like the regular Themis flavor. Also with Apple Silicon, obviously the CryptoKit, the iOS, macOS new official library for Apple, especially for ARM, it beats OpenSSL significantly on ARMs. So for Intel computers, OpenSSL is kind of the same as CryptoKit, but for ARM computers, wow, CryptoKit is much, much, much faster. And I think we have some benchmarks in Themis repo, so if you're super curious, you can go and check.
And of course, the point is that performance is nice, but if you do things wrong very quickly, you don't really get anywhere.
Yeah, good point. Yeah.
Okay, I think this is all the time we have. Thank you ever so much for your talk, Anastasia. If anybody wants to get in touch with you, it's Vixenthal on Twitter, right?
Yeah.
Probably best.
Just follow me on Twitter. Ask me security questions, cryptographic questions. If I can help, I'll help.
Okay, cool. Let's
continue with a great meetup, right?
Yes, the next one up is going to be Jeff Foley. He is going to be here in about 5 minutes. So grab a cup of coffee or some other beverage of your choice, and we will be right back. All right, and now it is time for the second part of our evening, the last talk of the event. So we have the one, the only Jeff Foley here for you. He is going to be talking to us about the OWASP MS project. Jeff, take it away.
Thank you, Cooper. Yes, so I was going to cover this very, at least I believe, very interesting project that has been around for about 3 years, too, with OWASP. But we're going to start with a little background, since I don't know how many people are familiar with this project. All right, and myself. So yeah, today I was going to cover an introduction to a mass, since, as I said, I don't know how many people listening are familiar with it. I'm going to give a brief demonstration and hopefully some recommendations on how to use it if you'd like to give it a shot, and just some interesting things that we've noticed while running this project, primarily from people that we've used it with, and where we plan on taking it, and of course, questions. If you have any questions, please feel free to just throw it into the comments. I think we're going to do our best to answer them throughout the talk. If that's not possible, then we'll try to address them at the end. So, who am I? Jeff Foley. I am a security researcher, so that's where my career began. I'm honored to be an OWASP leader now for this project. But throughout my career, I've been a technical leader, very focused on offensive security, red teaming, and a little bit on the blue side as well with vulnerability management. I am also honored to be an adjunct professor for SUNY Polytechnic Institute, where I teach penetration testing. All right, moving on. So what is the AMASS project? So put simply, it's attack surface mapping and asset discovery. It's a tool. So feel free to please go to this GitHub repo where most of the information about this project can be found, and of course, many ways to get your hands on it and begin using it. So this was originally developed honestly to help me understand clients. I mean, that it was to understand their attack surface and then discuss gaps with them in meetings. And I just didn't really feel like doing this manually all the time. There's a nice little story as to how exactly did it become open source. But let's just say I shared it with some people and they seemed to like it. And so we decided to continue supporting the community by making this better. I mean, not just me, of course, but users, contributors, everyone that's been involved with it so far. So I like to say here that I was impressed that OWASP understood how important this is, especially since I think it falls a little outside of the normal or typical OWASP project. Just that this isn't strictly, say, software security. It's a little bit more on the side of understanding infrastructure or understanding exposure on the internet, more from a host level perspective. It doesn't really go into your software's attack surface. So it's a little different, but I think the general attitude was, well, if you don't know these things are exposed on the internet, then how can you begin securing them? And OWASP told me that they wanted to add this to their portfolio, which was announced July of 2018. And yeah, it started like any other project, just as one of these like little incubator kind of projects, but it grew. It seemed to grow pretty quickly, and again, I'm honored that it's considered a flagship project today. All right. So I was going to go quickly through a little bit of, well, why is this important, or why should people be thinking more about this before we just dive right into this tool? So if you go look at some just studies that have been done recently, and I would tell you that from my own experience, this is all quite accurate, if not generous, in the numbers that came out of this study or survey. But companies, especially larger companies that do have what they claim are mature security programs, often have very inaccurate asset inventory or configuration management databases. I find this very interesting, given that I would consider this an essential function for security. There's other ways to track this information, such as listed here. You can use host-based agents, but the study shows that even when that's done, the numbers really don't change that much. The problem is just quite real. And until, what these last two bullets are trying to say here is, until a security program starts going beyond what these CMDB systems contribute to your understanding of your assets, until they start using tools that are really reaching out and trying to say, what do we have out there? They just don't get a very accurate view. That's pretty important though, I think, because for instance, from my own experience with vulnerability management, it's kind of hard to make sure that you're checking everything for vulnerabilities if you don't know what you should be checking. So if your inventory or your discovery methods are not good enough, then you're just not going to be checking all the exposed assets that you should be. Pretty serious problem in my opinion. So assuming we all agree, well then we need these tools that help us discover exposed assets. Yeah, so I guess I got ahead of myself, but these first couple of bullets say, I mean, these are very important. I've seen some other teams as well, not just vulnerability management, like threat hunting, where when they did not have this information either very up to date or just reliable, if they couldn't rely on the information to be accurate, it had a huge impact on their effectiveness, productivity, because they spent so much time constantly answering the question of what is this and where is this and who does it belong to, instead of tracking the problem or keeping on top of the problem, which is what they were there to do. And in general, it goes back to this, I would say, more easy to understand statement here, which is if you don't know it's there, you're not going to be able to protect it. It's just that simple. And which is it's interesting that blue teams are dealing with this, or people on the defense are dealing with this, since if you look at this more from the perspective of a battle or a war, this is the advantage defenders should have. They're the ones that should know what the battle space looks like. This is what the attacker should be having trouble with, not the defender. Attackers should be the ones that have to scout for what the battle space looks like and have trouble understanding what to do next. All right, so moving on with that. One more important thing about this is lots of times when I interface with these teams and I ask simple questions like, well, do you have a network diagram, something we can look at to understand your environment? You often get the people embarrassed to answer the question that they don't have it, or they don't have it up to date, or that it's just stuck in someone's head and they're not in the room right now, or something like that. So even if they could produce that, it means it's a snapshot that they took at some other date, right? It could have been months ago. And this is the best they have for what their own environment looks like. But attackers don't operate that way. Attackers are always reevaluating targets. They look at targets as they actually are at the time. So you have, again, this strange situation where the defenders know less about their own environment than the attackers do. And they're just not even looking at it the same way, I guess you could say. This is why as we shift to using these tools that can keep us informed about exposure, it needs to be a continuous process. Executed, you could say, as an attacker would, where it's constantly being reevaluated, it's being watched for changes, so that good questions can be asked, like, was that supposed to be put there? Or why did we take that down? Or, I mean, you can't really tell if a change is taking place if you're not continuously monitoring for the changes. These all seem like easy to understand concepts. It's interesting how many organizations do not operate this way, though. So I have a couple little factoids in here just about, when you do put these processes in place, it's incredible, though, how much faster you can respond to threats, or, for instance, an exposure that wasn't supposed to take place, because you would pretty much immediately find out about it and be able to fix it. All right, so coming back to OWASP. So OWASP is one of these tools, these network tools that are helping to solve this problem. But what exactly does it do? So it performs enumerations. That's what this is. Enumerations designed to start with something as simple as like a second level domain name and tell you, as every asset it could find that should be considered in scope or belonging to you that's exposed on the internet. And it performs this by collecting data that can be acquired using like open source intelligence and network reconnaissance, such as fully qualified domain names or DNS names, IP addresses, IP address ranges like CIDRs, and ASNs. So these are all, of course, network or internet infrastructure pieces of information, and very important, though, to understanding where an organization is on the internet. So as I already mentioned on the last slide, the tool also saves all this in this graph database so it can track the changes from one enumeration to the next, which is quite powerful. I mean, put as a simple example, you could set that up so that maybe all it does is from one enumeration to the next, if something new is found, you are notified about it. That alone could be pretty powerful. By saving the information, another thing that we can do that is very helpful, especially if you're a very visual person, is we can visualize the data. And I'll show you a little bit about what that looks like later on. So just real quick, continuing the idea of, well, so how does this work, or what does this mean exactly? So most organizations have multiple domain names they've registered. That being an understatement. I mean, many organizations could have thousands of domain names. And they usually use those domain names to create namespaces where they have subdomain names within the second level domain. So in this diagram that I grabbed from the source below, because I just think it kind of makes it easy to understand, the vertical domain correlation is where we are trying to get subdomain names, or names that have been used within a second level domain. The horizontal domain correlation is where you're making the association that, in this diagram, that google.com and youtube.com both belong to Google. So when you're trying to understand your target organization's presence or exposure on the internet, you need to understand all these namespaces and to what degree they're being used. And all this kind of falls into this activity just called domain name correlation. All right. And we use open source intelligence to help us with this quite a bit. So the OWASP Amass project supports over 50 different data sources. Some of these are you can use right out of the box. Some of them you have to register to be able to use them. But it's quite a lot of information at your disposal so that you can just have Amass do all the work for you of digging up the exposure that an organization has on the internet. Between all the registrations that they've done for names and IP address ranges, and just for instance, like passive DNS records where it shows activity within these namespaces. And if the 50 plus data sources that we offer are not enough, that's not a problem either, because you could say similar to Nmap, Amass offers the ability to write your own scripts that are written in Lua, again, similar to Nmap, to expand your data sources. So you could, if you knew about other ones that you wanted to be able to use, as a simple example, maybe one of them being your own asset inventory, then you could easily roll that into your use of Amass. Excuse me. Yeah, so we also give the user the option of using more active methods, such as, for instance, a pretty powerful one is the ability to take these IP addresses that we find and then have Amass reach out to them and attempt to grab TLS certificates. These active methods, though, are not turned on by default because I guess at the moment, for now, the policy that this tool has is that unless you give it permission, it's going to behave in such a way that hopefully it won't reveal your position or your activities. So you should be able to use this and not draw too much attention to yourself or have the target organization become aware of your activities. But if that's not a problem, or if this is your own organization that you're using it against, then I would say definitely use the active methods. They contribute to the findings, or they enhance the findings. All right, this is a pretty big one. Since that name correlation is a pretty big deal, DNS brute forcing is a pretty important part of what we do in a handful of different ways. I would say the big ones being just your good old dictionary attacks using a word list like most tools allow you to do. But we also do some other things that are pretty powerful, like we call them name alterations. But you could think of them as DNS name mutations, but where we take a name that was successfully resolved and then we start playing with it and making new names that are slightly different. So these similar names are then attempted, and it's a pretty effective method. And then, of course, we do reverse DNS sweeping. So that's where, we have a name that resolved to an IP address, and now we say, well, what are the chances that maybe around that IP address there's other names or other assets belonging to the same organization? So we sweep around that IP address asking, are there DNS names associated with these IP addresses? That's also a fairly effective method. It depends on the organization and how often they're giving reverse DNS records to their assets. And we've played around with some other arguably more interesting methods, like using n-gram frequencies and Markov chains to try to identify similar names or names that have a high likelihood of being used, given that, or based on the names we've already seen used. So that was pretty interesting. There's a lot of work to be done in that if it's going to be worth it, I guess I would say. So part of what makes this tool different than a lot of other options that exist out there is, I mean, unless someone can show me that I'm wrong in what I'm about to say, it's the only tool that I found so far where it has this cyclic design, or this engine where it's event driven. So what that means is all these techniques, all these data sources, when they find, so you could say they generate potential names and IP addresses and things that look likely to belong to the target organization. And when it's confirmed that they do belong to the organization, or at least to the best of our ability to determine that, that information is then shared with all the other data sources to give them the opportunity to say, oh, wow, this was discovered. Well, then what else can we find based on that? Of course, keeping all the results in scope, at least for now. Right now, we're pretty strict about scope, but I'm thinking of creating options to loosen that a little bit for people that just want to see what could be out there. But yeah, it's a pretty powerful technique, because I guess you could say what it means is, instead of just asking a data source, have you heard of this before, and then see what it gives you back and then say, okay, that's it. This allows you to keep the process going until, I guess you could say literally, there's just nothing left to look into. And it definitely finds or creates more findings. An interesting example that showed up really quick when we were developing this is this alt and sweep technique, where you have a name that was resolved, and that name is then shared with the name alterations brute forcing method, and it creates new potential names. If any of those names are successful and the IP address that they resolve to is in a, say, different subnet than the original name that we started with, then when we do reverse DNS sweeping around the new IP address, there's this potential that we're going to find a lot of new names. And all those names now are confirmed names, and they now go back to the name alteration data source, as we refer to it as, and the process continues. So, I mean, it's funny how, depending on your target, that alt and sweep method can go on for quite a long time, actually, assuming, of course, they have a lot of reverse DNS records set up, and they're using similar names in their naming scheme. But it happens. It's a typical situation. So yeah, there's a lot of data sources that are built into Amass where they heavily contribute to this cyclic or recursive process. But it's a big reason why this tool generates more findings than alternative tools. It also contributes to why it takes longer. So if you try this out, you'll see what I mean. It takes longer to run this because it's just working more to find more. All right, getting closer to what I imagine most viewers are looking to see, which is, so how do they get their hands on this? So if you want to follow along, or you just plan on trying this out later, I would say either fire up Kali Linux, and it's probably in there already. If not, you should definitely be able to install it just by saying install Amass. Snap can make it possible for you to install it, although I would just warn you, Snap has an isolation method it uses for all the things that are installed, and there are some limitations it imposes on a mass that can quickly become frustrating. So it's probably not the best option if you're going to use a lot of Amass's features. Homebrew has you can install it using Homebrew. You can get a Docker image for this. You can go to the repo and, we have pre-built binaries. Or if you're just comfortable with Go, I would say then follow the instructions on the repo and just go build it. It's probably one of your best choices. All right. So I'm actually gonna skip this slide because what potentially can show up here is the tool being used. But what I was gonna do is show it to you myself. So in the interest of time, though, what I've done is I don't want to actually run a full enumeration. It takes too long. We'd be sitting here just talking while we're waiting for this to finish. But what I would like to do is show you what it looks like when you use this and what some of the things are to think about when you execute your enumeration. And I will show you what the data looks like and things like that, because I did some of these prior to the presentation. So we'll take a look. But for instance, if you download this and you've got it on your machine, and now you're saying, all right, what do I do with it? You would, of course, find out where the binary is, or if it's in your path, then you're all set. But for me, it's right here. Now, if you just kick this off, what you should see is this extremely basic help screen. So, because it has no idea what you're trying to do right now. But if you pick one of these subcommands that are right here, and then ask for help, for instance, like the enum subcommand, now you're going to get some more interesting information on usage. And as you can see here, there are a handful of options, right? So that's why I want to talk about this a little bit. So how do you know what to use? How do you know how to control some of the behaviors of a mass? All right, so here's how I like to use it. Personally, I like to see where the data is coming from. So this source flag will show you, along with the names and the IP addresses, the source that originally found it. And I kind of like to know what it is. I also like to see the IP address. You have to tell it to reveal it. And I normally use brute forcing. So you have to turn that on, because it's not, I turn it off by default because it's definitely a expensive thing to run. But here's something to think about that isn't completely obvious, maybe not even from the documentation, given that it's a little new. But if we were to move forward with this, so the D is domain, and it's also your scope. So it determines if it's not within this domain, then it's not going to be considered an asset that belongs to this organization. But if we just fire that off, which will work, Amass is going to go find a lot of public DNS resolvers to use for this enumeration, and it's only going to use each one a little bit. So the purpose for that being, hopefully that way you don't exceed thresholds or anything like that for what they consider reasonable usage. The only problem with that is it also means that there's a chance you're going to get resolvers that are not trustworthy, or they're not going to answer your requests because they might be out there, but maybe they're not working properly anymore. And you're probably going to end up with a higher rate of like resends that have to be done on your request. And if your enumeration is not extremely intensive, what I would recommend you consider doing is defining your own resolver. I don't usually recommend that people use the same resolver that their system that they're running this from is using. In the case that you did violate what's considered reasonable usage, because now your system won't be able to resolve DNS. I usually say use something public. That way, it won't matter too much if you can't use it anymore. But for instance, like a very high performance public resolver that we all probably know is this one. But you still have one more job to do, which is if you only define that, it's still gonna only use it to that very at that very slow level I mentioned. But for instance, Google's resolver is quite capable of handling far more traffic, and it won't be too upset with you. So what I would say is define your max DNS queries and set it to something like 500 per second. So now you have a very reliable resolver at a reasonable rate. It's not exactly extremely fast, but it will keep things moving. And then you could define your target organization or domain. And by the way, for instance, this can have can be comma separated. So can like the list of resolvers. There's a lot of things in here. If you look at the usage information where it says they're comma separated, so you can have a lot of values. Or some of them support, for instance, using like files instead. So you could have something like that, which a lot of people use this. So what I'm not going to do is actually run this right now, because otherwise we'll just be sitting here staring at it and it'll look kind of neat maybe, but it's going to be a waste of our time. So instead, what I'd like to do is we're all just going to assume that I did kick that off, and now we're going to take a look at the information. So as mentioned earlier, OWASP amass both at runtime and when it's finished is saving the information in a graph database. And what I mean by at runtime and when it's finished is at runtime, it's saving this all in memory, and it's doing this very quickly. But all that data is then stored into a permanent location when it's finished. So for instance, by default, it uses a file that stores the database. And we can pull the information back up by just saying, show us everything that we know about that domain. So what we have here is the names that were discovered and this summary information at the end where it says, you know, here's how many names were discovered, here are the methods that were used to discover how many names, and this breakout of the ASNs that the names fell within. So as you can see, the majority of OWASP's namespace are behind Cloudflare, but a few were found in AWS. If you want to see just the names, for instance, but with source information and IP information, you can do that here as well. So since we have a lot of IP addresses, it's a little bit crazy, but so what you have here is you have the source, you have the name, the DNS name, and all the IP addresses that were associated with it. So this can be interesting for many reasons, obviously, because you could say all of these could potentially be further investigated manually if you felt there was more to be found. But also a very important thing to know about is, so if we go to the usage information for this subcommand, all this can be pulled out using the JSON flag here. So you can simply give it the JSON file you want it to go output this to, and the target domain or domains, and all this information will just get dumped into JSON, which makes it real easy, obviously, to extract it for your needs. I find that pretty useful, but it does have to be done if you want the complete information. It has to be done using the DB subcommand. So there's also JSON that can be output as it's being discovered from the enumeration, but there's the possibility that due to the cyclic nature of the engine, data can be discovered later and put into the database that was not found at the time the asset was discovered. So just something to keep in mind. These are the things I wanted to cover to increase your, well, so that you could get maximum value out of this. So I think this would be a good time, though, to switch back to the content. There's a lot of things that you can do to play around with this. I would encourage you to find some of the other videos that are already out there where I've done training sessions on this, and we really dig into everything from how to do effective brute forcing with it, how to write your own scripts for new data sources, things like that. All right, moving along. Okay, so I wasn't going to do this on the command line. I figured it would just look a little nicer here. But if you have multiple enumerations of the same target, like OWASP.org, and then you use the tracking subcommand, or track, it will tell you between what periods of time these enumerations took place and what was different. So it will say, well, it found these new names or new assets. These moved to different IP addresses, and maybe some were removed. Although I would urge you to consider it possible that it just didn't find them, as opposed to they were actually removed. I would definitely verify that yourself. But all the same, this is extremely useful because let's say your target is something much larger than OWASP, where we're talking, hundreds of assets or maybe more. This really helps prune down what you want to focus on, right? As opposed to just looking through all this data. What if you could just say, well, just tell me what changed from one to the next, or from the last time I looked at this. And yeah, going back to this idea of, so what about when you just want to look at it and try to understand what this all means? So right from almost the beginning, I mean, really early when this tool was released, this feature was available, because I'm a very visual person. But what you're seeing here is where we've taken the graph database and we've leveraged the infrastructure relationships that have been saved in the database to recreate kind of like a layout for the assets. So everything from the actual domain names to these green ones are the subdomain names, which, for instance, like say they have a CNAME or alias, could end up pointing to a different organization or a different domain name. We have orange, which is the IP addresses for these names and the CIDR ranges that they fall into. That's the pink ones. And the ASNs that those ranges are associated with. And there's some other interesting ones, like these are mail servers, these purple ones. The light blue ones are name servers. The yellow ones are pointer records, or as I mentioned earlier, the reverse DNS records, so that we could go from an IP address and then get this name here. What you'll probably find if you use this feature is some of the structure that shows up in these graphs, it repeats itself. You'll find it again and again from one organization to the next. Like, you know, this is probably your classic Gmail architecture, where, you know, this organization's using Google Mail for its email. You know, there's other similar ones that, for instance, Microsoft, their services are very easy on the eye. Like, it's trivial to pick it out from the graph. But what I like about that is it kind of makes it easy to decide what portions of the graph you probably don't need to be looking at, and focus in on what's different about this organization from others, and really get an idea of what should we be concerned about or questioning, or making sure these things are supposed to be here. I would encourage you to play around with this. It's a pretty powerful feature. You can also look at it differently. Like, let's say this is just not doing it for you, or it's hurting your eyes. For instance, Maltego, which is a very powerful tool for visualizing infrastructure and personnel information. You can output your data that's discovered by a mass into a format that then can be imported by Maltego, and it will, you know, generate rather complete graphs or diagrams of the assets and all their dependencies and things like that. So this can be very useful as well, especially if you're going to use this for like collaboration with other people. All right, so I'll try to get through these. I just wanted to share some interesting things that we've found during the life of this project. For instance, you know, maybe it's just me, but I still find it kind of amazing how every single organization we've encountered where they've allowed us, you know, to use this tool against their namespace, when we've shared the results with them, they've all been shocked by what they found. Like, they all saw something in there that they said, wow, that wasn't supposed to be in there, or we weren't aware that this was exposed. And it didn't matter how large this organization was, how impressive their security program was. I don't want to throw out names, but let's just trust me when I say some companies that if I did tell you the name, you would probably say they would have things under control. They still had these issues. No one seems to have this completely under control. And I find that very interesting. So I would really encourage everyone to try to use it, because no one seems to not need this right now. I've also found it kind of interesting when I was able to learn more about these organizations that many of them are not able to monitor their DNS traffic, like specifically the traffic coming in, like the requests coming in. I consider this valuable information to understand interest in your organization, or even suspicious activity that, you know, could seem outside the ordinary, or what you want to see for proper use of your services. And you know, when I looked, like I said, when I looked into these organizations, many of them even had this completely outsourced, so that even if they wanted to start using the data, they couldn't, because it wasn't really under their control anymore. I don't know, I find that a bit shocking. It seems so valuable and like quite a cost to give it up. I also found that many blue teams I've spoken with they don't seem to. So when they're considering how to protect things, many teams have told me that they just started, or either they never have, or some impressive teams have told me they just started to think about how an attacker is approaching a target, or what an attacker needs to do in order to successfully compromise a target when they're considering their own defensive measures. So again, maybe it's just me, but wow, you know, like that would be my initial approach. Would be, well, if we're going to prioritize, you know, resources, we're going to try to stay within budget. Let's consider, in our situation, how an attacker would attack us, and what does the attacker rely on in order to do this properly, or with a high level of success. And let's start there and start reducing what the attacker has to work with. Let's minimize their options. Let's reduce their visibility. Let's force them to, you know, let's increase the likelihood that they're going to come to where we want them to come, not where, you know, we want them to stay away from. You know, sometimes this is easier said than done, obviously, but if you have any control over this, that is what you should be doing, so that you're minimizing the attacker's options. But instead, so many of these organizations, they have their attack surfaces wide open. So it's like a playground to an attacker. It's trivial to see what this organization looks like, where would be a very safe place to try to come to get in, and then, you know, pivot to more interesting places. There's just so much a blue team can do to minimize this. So I just find it very interesting that this isn't the norm. It's currently considered the advanced method. But I would encourage anyone to maybe use this concept or approach when they're considering their next how they're going to protect themselves. And this is probably one of my favorite slides. This is where, you know, I want to share with some people what we have in mind for, so where are we going to take this? So the largest, or the most exciting thing in my mind right now on this list is JARM. And if you've never heard of this, I would say, please go read that blog post from Salesforce Engineering. This is an incredible contribution that they've just recently made this month to perform TLS server fingerprinting. Why is that important? Well, for the MS project, so far, DNS, you could say, has kind of been the only ground truth we have to work with, right? It's the only thing that we can say. So we have this thing we found. Does it belong to the organization that we're trying to map out? And if we can't get some, you know, something with DNS to say, yep, it falls within the scope, or it belongs to the organization, then we have to let it go, because we don't really have a lot of ways to say, wait, you know, we have another reason to believe that it belongs to this organization. But JARM fingerprinting creates a whole nother dimension where now we have another place to ask the question, does this belong to the same organization? Because these fingerprints are so unique to who actually stood these servers up, that if we find a JARM fingerprint on an asset that we can say, we know this belongs to, let's say, you know, OWASP, we know it's their server, because we do have, say, DNS to back that up. But now we could start asking the question, well, has anyone seen this JARM fingerprint anywhere else? Because if yes, then let's include those assets in the in our discoveries or findings. Also, what if it reveals new second level domains. So going back to the idea of the horizontal domain name correlation. So what if we discover a whole nother domain that we didn't know about because JARM revealed that that was part of this organization's namespace? You know, it just opened the scope for us. I'm just very excited about this. I can't wait to bring JARM into how a mass operates, so that we have this other question we can ask that will open the doors for new possibilities. There's other ways that people can obviously use this fingerprinting technique, and I would just encourage everyone to start learning about it. It's such an amazing contribution from Salesforce. We would like to, so right now this is a tool, right? It's a tool like Nmap. You saw me playing with it. You use it at the command line. I think it would be powerful if there were other ways to deploy this so that it doesn't have to run on one machine. It could run on several machines, but it would be as if you had one execution of the tool, but distributing the workload across the different machines. It would also help make it harder for public DNS resolvers to know, is all of this coming from one place or not, right? I mean, it would make it easier to stay under the thresholds that cause resolvers to limit traffic. That would be very helpful. But it would also just be helpful for resource management. I mean, some of these enumerations can take a long time and they can use up a lot of memory. It'd be great if we could spread that out, you know, in like a cloud environment or something like that. So that's on the radar. We'd like to, you know, continue the investigation of the intelligent name guessing. I think there's some promise there. We just need to do a better job doing our homework on that, because I think it would, if we wanted more and more names to guess and we had the time to entertain that, that would be probably our next best place to go to get more names. I would like to be able to intelligently profile DNS resolvers. So as I mentioned earlier, for instance, Google's public DNS resolver is amazing. It's, you know, extremely high performance, but there's a lot of them out there that are not, and you can quickly overwhelm them if you're sending too much traffic to them. But I mean, what if we could really accurately feel out how much each one is willing to accept, and we just used them within their limits, right? I think this is quite doable. It just needs some attention to be put on this. We're already handling each resolver separately. So from a kind of like a performance perspective, we're already breaking out. We have, like, I guess you could say, separate instantiations of code for each resolver. So it wouldn't be that hard to say, well, in addition to doing that, let's just start keeping track of, how well are they responding, and maybe we should slow down, maybe we can go faster, things like that. And as you can imagine, some people just don't want to use a tool that is kind of like Nmap, right? They don't want to be on the command line. Some people have asked if we're thinking about creating web interface to this, or like dashboards, or the ability to run it kind of like a service that they could put somewhere and then just check a web interface. I think these are good ideas. I understand not everybody wants to run things from the command line, so I'm definitely for the idea of doing this. I just think we need to take our time and do this carefully, but I'm supportive of this effort. And with that, look at that, pretty good timing. Questions?
Yes, we do have a few of those. The first question I have here is by Nathan, who asks, how does a mass tackle wildcards in subdomain enumeration?
That's a great question. And it does. It's a harder problem, I think, than some people realize. Perhaps Nathan understands. But so it's a mixture of, we first check, where did we get this name from? Is it a trustworthy source, or or is it something like brute forcing where it was just made up? And if we don't have any evidence that this was a name that came from the target organization itself, therefore we have a good reason to believe that it's legitimate, then we make sure to do the DNS wildcard detection, where so the typical process for that, right, is where you generate false names and you check how the DNS resolvers respond to those names. If they're giving you what seem like valid answers to what you know are bad names, then you can be pretty sure that it's because they have a wildcard there, or they could just be a bad resolver. But either way, we mark that portion of the namespace as we can't trust when we get an answer that it's actually a legitimate answer. So if in the future, if we resolve names and they match what the wildcard gave us, then we don't accept it. But you have to be careful how you use this. It's a little sensitive. If you want to join our Discord server, I would say come to me sometime on the Discord server, and I could explain or show you the code where this actually takes place, and you could get a more detailed answer.
Okay. One question I had was, you were being very specific about the order of the parameters. Is that actually important to the tool? Because you made a point of ending with minus the domain name.
No, good question. It doesn't matter at all. The flags can be put in any order you like.
Okay. Then we have one more, which is, what is the advantage of using a graph database for a MAS, aside from easily creating graphs?
Fair question. And so actually, I had a slide on this for this, and I considered keeping it in for this presentation. I'm glad I didn't, given the time this took, but a lot of people ask this question. It's a great question. I guess the simplest answer I could come up with is the internet and its infrastructure. Internet infrastructure is not a list. It's a graph. And there are a lot of relationships that we're keeping track of, both in the infrastructure and the what I kind of call security relationships, that are easier to represent as a graph than it is as tables. Not that it's impossible. I'm not sure there's anything that's impossible to represent as a relational database that you can create in a graph database, but it's definitely a lot easier to work with it as a graph, both conceptually and to a degree computationally.
Okay. I was also wondering, you've mentioned that you rely a lot on DNS. Have you considered potentially using DOH or DOT? So it's still DNS, but then over HTTPS, or using the DNS over TLS. Does that play a role?
We used to. So so this is a long time ago. I think it's before this was a OWASP project. We played around with using DNS over HTTPS, and it was fun. It worked, but it definitely was not as fast. I've heard though that there's been improvements on that front, so I don't have specs right here to say why we have to do it one way or the other. The other reason is there's some interesting things you can do with. So a MAS by default tries to get the DNS resolver to hide your location to the authoritative name server. Now, there's no guarantee the resolver will do this. So if you want to make sure it's actually happening, you have to go find out the policy of the organization that's making the resolver available. But for instance, Google claims they honor this. So by doing that, it makes it so that by the time the target organization sees the DNS request, it should not give them the information necessary to know where did this come from. Not that you necessarily are losing that with DNS over HTTPS. Maybe I'm just paranoid, but since HTTPS sends so much more information, I guess it just makes me think, why send more? Let's continue sending as little as possible. That and the performance, possible performance issues just makes me think, let's just stick to the way we're doing it. But if anyone wants to present to me why I should reconsider, please do, or come, like I said, come to our Discord server, and I'd love to talk about it.
Okay, I got one more question from Nathan B, who already said he will definitely join the Discord. He was asking, how do you determine if a certain domain belongs to a target organization?
Right. So these are good questions. I can't wait to meet Nathan. So put simply, you would think initially you would say, well, you can't, right? Unless they tell you what it is. But there are things you can do with WHOIS, assuming, of course, they're not using completely private WHOIS records, which, of course, makes this even harder. But there's things you can do with WHOIS and reverse WHOIS that allow you to take common data from one WHOIS record to another and search for it, right? And find more domain names that, I guess you could say, hopefully belong to the same organization because they were registered in a similar way, things like that. There's also, try to think of all of this data that we're collecting as having the potential to be like leaking hints that this could belong to something else as well, or be associated. The big change coming up in 2021 for the OWASP project that's going to make this even easier, your question, how do we find more domains that belong to the same organization, is that JARM technique. I can't wait to see what happens when we completely implement this and it starts showing us new namespaces, new subnets and things like that that are clearly part of the same organization based on the setup and maintenance configuration and things like that of these web servers, and they reveal new assets to us. It's going to be quite exciting, I think. But good question. I mean, it's a hard problem. If you're working with a client, I would just say, ask them, right? It's easier that way. Just get them to show you all the names they've registered, because it's easier to just start with that knowledge up front.
Okay, we got one. Actually, it's already two questions. So he said, I've got a question from Dirk W, who said, you said something like using TLS is noisy. Could you go into more detail? But he then clarifies that was very early and probably you didn't mean TLS for enumeration, not DOT, DOH. I'm struggling
so what did he say I said was noisy?
The use of TLS. I think it's in the context of it would be noisy towards the DNS resolver so that they can identify you and potentially block you.
Yeah, if I did say TLS, I might have just made a mistake, but maybe what was being discussed was the fact that the TLS fingerprinting is active, similar to like actively going and pulling TLS certificates. So it reveals your position because you have to make a direct TCP connection to the target. By default, OWASP does not make any direct connections from your system where this is being run to the target, to any of the target's assets, only to DNS resolvers. And they're not authoritative name servers. They are public resolvers. If you turn on active mode, then there's no guarantees. Like now it will attempt to do zone transfers. It's gonna, like I said, pull data directly from the assets discovered. like TLS certificates. So if that's a great thing to do for more information if there's no problem with them noticing that you're doing this. I mean, most companies, interestingly, still don't notice, which is like, oh wow, okay, but they don't, a lot of them. So I would kind of encourage someone to just do it anyway, because there's nothing illegal about any of this. I don't know if that answers the person's question or not.
I'm going to say hopefully it does. There is a bit of delay between what we say and what YouTube can hear, but it was the last question. So, Jeff, thank you very much for your talk. So if people
thank you for the opportunity.
If people want to learn more about NMS, it's an OWASP flagship project. You should be everybody should be easily capable of finding that. Google is your friend should you need to. And the question asker answered that, yep, that was indeed the answer to his question. So he's happy.
If I could just do a little plug real quick on.
Sure.
Please feel free to obviously come to the repo, read about, for instance, how we our interest in contributors, how we communicate with people, like I kept saying, pretty repeatedly. Come to the Discord server, and we are a very welcoming project. So if you find this interesting at all and you want to contribute in any way, don't hesitate. We bring in contributors regularly, and we've had some pretty amazing contributions. Or even if you just want to, of course, fire us a PR or something like that. But please come and join the party, so to speak. I've had some people tell me that they didn't realize that it was that easy, or that they didn't have to say, I don't know, get invited. So yeah, there's no need for invitations. Invite yourself, and we can discuss all the details in the Discord server. Okay. Thank you for your time. Thank you for listening, and we look forward to either hearing about your success with Amass, either on Twitter or Discord. Bring all the goods and bads to us. I'll end it there. We want to know everything.
Okay, thank you, Jeff.
All right, thank you.
This is the last talk of the OWASP BeNeLux days. So we hope everybody at home has enjoyed them. We will be editing out the individual talks and put them online shortly, and we will put out tweets to the individual talks, etc. The usual things that you can expect from us. We will obviously be doing more talks throughout, well, not probably this year, but in the next year. So keep an eye on the OWASP Netherlands Twitter feed, the OWASP Belgium Twitter feed, and thank you ever so much for your time. Thank you to our speakers, that is Jeff Foley and Anastasia Vojtova, and our speakers from the previous days. We had a lot of fun. We hope you did as well, and we hope to see you, preferably in person, but at least healthy next time. Bye-bye.